Hello dears, welcome back to our chemistry curriculum, and today we will continue with section 5.1 and 5.2, ionic compounds and chemical bonding. As we have mentioned before, we have about four types of chemical bonds, which are ionic, covalent, hydrogen and metallic bonds. The ionic bond is a bond is between metal and non-metal, where metals lose electrons and convert into positive ions or cations, while nonmetals gain electrons to be negative ions or anions. The main target for both is to achieve the octet rule, or to be having 8 electrons at the outermost level to be stable. Today we'll continue the properties or to the characteristics of ionic compounds and the covalent or molecular compounds. But before mentioning these properties or characteristics, I need you to know something. How could you know that? Which type of compound is this formula? For example, we have here calcium oxide or CaO. How can you judge the type of this compound or whether it is ionic or covalent? Another example here, we have, for example, CH4 or methane. To know the type of the compound, you should remember something, that ionic compound is formed of metal and non-metal. So any ionic compound must start with a metal. What about the covalent compounds? It consists of non-metal, yes, combining with another non-metal. So it may contain two or more nonmetals combining together by sharing electrons. So to identify the type of compound, you should know the first element in each compound. If you found the starting element or the first element a metal, so it will be ionic compound. If you found the first element non-metal, it will be covalent compound. Okay. Then you have to know the characteristics of all ionic compounds and all covalent compounds. Here we'll mention the characteristics of ionic compounds, and the opposite is for the covalent. First, most ionic compounds have high melting point and boiling point because they are strong and have a strong attraction force between its elements. The second and the most famous or familiar about ionic compounds, that they have solid state at room temperature, except some rarely gaseous compounds at room temperature. So on the other side, the covalent compound, you can find that they have low melting point, low boiling point, but about the state, you can find covalent compounds in solid, liquid, and gaseous state at room temperature. The solid ionic compounds are hard and brittle. They are solid, so it is hard, but brittle, so can be easily broken. On the other side, covalent compounds are the same. The solid of it, they can be broken easily, so they are brittle too. Ionic compounds has a very remarkable property, which is the crystal lattice. You can see here on this photo or this figure that there is a definite pattern arranged of elements of a certain element. For example, you can maximize this photo. Here, you can see a cube of crystals of atoms. This arrangement of atoms in a certain regular pattern is called crystal or crystal lattice. And this gives most of ionic compounds the crystalline shape, as you see in table salt and so on. which is sodium chloride, as you know. So ionic compounds form a crystal lattice, which is the regular pattern in which atoms are arranged in a compound. Okay. On the other side, the covalent compounds have no crystal lattice, no arrangement, except some compounds which are rarely found, like sugar, for example. It has a crystalline shape, but it is a covalent compound. Finally, the final property, which is the most important property here in ionic compounds and also in covalent compounds. When I bring a solid covalent compound, for example, table salt or sodium chloride, if I try to conduct electricity using solid covalent ionic compound, it will be poor conductor of electricity. It will not conduct electricity. Okay? But I know that ionic compounds have charges. Positive charge for the metal at the first, or the metal ion, and negative charge. So if I have charges, I should conduct electricity, but in solid state, no compound can conduct electricity. So how can I conduct electricity using ionic compound if they are in liquid or aqueous state, as we call it? And it means that they are dissolved in water. I can write here aqueous or AQ, abbreviation for aqueous, means dissolved in water. So this solution will be good conductor of electricity. Okay. What about the molten form of an ionic compound? So if it is molten, it will conduct electricity too. Okay. So very important questions come on this part. If there is a solid ionic compound, it will not conduct electricity. If it is aqueous or molten, it will conduct electricity. What about covalent compounds? You can say that all covalent compounds in all their states are poor conductors of electricity. Okay. Here we can see some forms or some shapes of crystalline shapes of ionic compounds. And here's the arrangement in a certain pattern of ionic compound elements, positive ion for sodium and negative ion for chlorine. And finally, I need you to answer the following questions about ions. I need you to draw an example for a covalent compound between hydrogen and oxygen in water compound, and also the bond between carbon and oxygen, carbon dioxide. Draw them in your chemistry notes and let me see them next week, inshallah. Thanks for listening and go. Bye.